Hello and welcome to this episode of Math with Martinez. We are in our Pre-Cal Unit 1 looking at function graphs, attributes, and applications. And in this episode, we are going to be focusing on our third learning objective, which is to analyze and describe the end behavior of functions using infinity notation to communicate this characteristic in mathematical and real-world problems. So let's go ahead and go to those notes on end behavior. What exactly is end behavior? Well, it's just answering the question about what's happening at the ends of our graph. So let's go ahead and read this more formal definition. As x moves towards positive infinity and negative infinity, what end behavior is it describes what's happening to the value of f of x. So let me kind of illustrate that for you and give you the algebraic way in which we write this, the mathematical notation. So right here, as we're reading, it says as x, and then this little symbol right here, this means approaches. Because we actually can't ever get to infinity. We read that as x approaches infinity. And let's make a little note here in our side margin, little bubble here. When you see this, x approaching infinity, what that really means for us, if you're thinking about over here on your coordinate plane, when x is approaching infinity, that's going to be if you were to move like way out in this direction for all of time, right? So what we're saying is, as we move right on the graph. And conversely, when it says as x approaches negative infinity there below, what that means, negative infinity, x values being negative, is going to be moving in this other direction. So if we're moving to the left on the graph, then that's what is implied by as x approaches negative infinity. So that's going to be really helpful if you keep that in mind while you are answering these questions. So as x approaches infinity, as we move to the right on the graph, f of x is approaching what value? Again, see, we have that symbol for approaching. What's happening as we move in that direction? As we move this way, what's happening to our f of x? What's happening to our y values? Well, as we're moving this way, the graph is going down. It's going down, 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 down to negative infinity. It's approaching negative infinity. And conversely, as x approaches negative infinity, that means as we're moving left on our graph, what's happening? If we're moving left on our graph, we're going up to infinity. Great. Next, as x moves towards positive infinity and negative infinity, like we did before, it's possible for f of x to approach a certain value. That's especially true when we have our rational functions or other functions that have these asymptotes, right? When you have an asymptote, what might happen here is as we're moving, as we're approaching, going to infinity, that's going to be as we're moving to the right. So as we move to the right, what's happening out here? What height are we approaching? We're approaching a height of -1, where that asymptote is. And similarly, in the other direction, as x approaches negative infinity, that means as we're moving leftward, so left, 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 left. If we could go out here left forever, what would happen? Again, we'd be approaching -1, that value where we have an asymptote. So in other words, end behavior describes the height of the graph as our x values get very large or very small. So let's look at a few examples of all different kinds of functions and identify and describe the end behavior here on this next page. Looking at this first exponential growth function we have, as x approaches infinity, that means as we're moving to the right, what's happening here? We're going up, 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 up to infinity. And as x approaches negative infinity, that means moving to the left. If you're traveling leftward on the graph, you're going to be going down, 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 but this is an exponential function, so you should recall that there is a asymptote there, which means we're actually going to be approaching the value of 0. All right. So look in here, next one just below. Let's look at this red one just below. We'll do the first column and then the second column. What do we have here? It's another exponential function, but what's different? Let's see. First thing, as x approaches infinity, that means as we're moving to the right out here. Well, now that's the case where, again, we've got that asymptote, so we're going to be approaching a height of 0. We won't actually touch it, but we will approach it, indicated by this symbol. Not saying that it's equal, but saying that we are approaching 0. And in the other direction, as we approach negative infinity, as our x's approach negative infinity, that means as we're moving to the left on our graph, it's going up to positive infinity. Wonderful. Okay, now for this one, we actually are going to have to do a little editing here. So let me grab my white pen. No, let me first do blue. All right, so the first question, as x approaches infinity, that means as we're moving to the right. As we're moving to the right, what's happening? Well, for this logarithmic function, it's going to keep increasing upward, unbounded, all the way to infinity. But there's something kind of unique happening here, and that's why I'm going to erase where it says as x approaches negative infinity, because you know for a logarithmic function, I can't go over here, right? This graph, when it comes to moving leftward, there is a place where it's not going to pass because we have a vertical asymptote right here at x equals 0. So what we're actually approaching here is as x approaches 0, as our x values are getting closer and closer and closer to where we have that asymptote, what is the height that our function is approaching? Our function is approaching negative infinity. Cool. All right, halfway done. Let's look at these other 3. Why don't you guys try the next 3 here? A rational function, quadratic function, and cubic function. Take a moment, pause the video, and try those on your own, and then we'll check them together. All right, so as x approaches infinity, that's moving to the right, we're going to be approaching that asymptote for this function at a height of 0. And it's true on the other side as well. As we move to the left, again, we're approaching where our asymptote is, which is at a height of 0. For our quadratic function, if we're moving to the right, if we're letting our x values approach infinity, moving rightward, that means we're going to be going up, 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 all the way to infinity. And the same is true in the other direction as well. As you move left, that graph goes upward, unbounded to infinity. Now for this last one, unlike the previous 2, it's not going to be matching. Your end behavior on the 2 different sides are going to be different. So as x approaches infinity, that's the side over here. If we were continuing to move to the right, if we were moving right on this graph, what's happening? To the height of this function, what are we approaching? Infinity. It's going up, unbounded. But as x approaches negative infinity, that means moving left, it's going down. So our function is approaching a height of negative infinity. There you guys go. That is the end behavior for these graphs. Just kind of a deep dive on one of the key attributes of our functions that we'll see throughout this year. If you had any questions about end behavior, would you please take a moment and share those now? And until next time, stay fired up.